Okay, let's talk about the extreme value theorem. This theorem states that f of x, the function f of x, has at least one absolute maximum and absolute minimum on the interval a to b inclusive if this condition is met. If f of x is a continuous function on the interval a through b, then this must be true. And when there's a bracket, that means a and b are inclusive, so you include the points a and b. If the brackets, or if they were parentheses, if it was a through b with just open parentheses, then you're excluding a through b, so it's everything between it. But since the theorem is closed brackets, you include a and b. Okay, so the first question says, find the max and minimum points on the interval -1 to 2 for the function 3x to the 4 minus 4x cubed. So to find the maximum and minimum points, the points that can be maximum and minimum are either the endpoints or critical points. So endpoints is just x equals -1 and 2, which is the interval that they gave. And critical points are points of horizontal or vertical tangency. And what that basically means is the slope of the point is either 0 for horizontal or undefined for vertical. So to find that, we need to find f prime of x equals 0 and solve for the equation of x. So first, let's find f prime of x. So just by using the power rule, we can say that the derivative of f of x is just 12x cubed minus 12x squared. And now we're going to set this equal to 0. And now if you'll see, there's no points where it's undefined because there's nothing in the denominator. And this is just a straight, if you factor out the x, it's just going to be a quadratic. So let's take out 12x squared. And we're left with x minus 1 equals 0. So now 12x squared equals 0 and x minus 1 equals 0. So now we have our answers. X equals 0 and 1. Now these are the critical points. So now we can say that our critical points are x equals 0 and 1. Now remember, these points are only where the slope is 0. So that means this is where there's a horizontal tangent line. There's no vertical tangent lines in this because we already saw there's no denominator where we can set it equal to 0. So now what we do is compare the y values for each of these points. So let's make a little table. X and f of x. And we have, now we put all our endpoints and critical points. -1, 0, 1, and 2. Now from here, we just find f of x in the original equation when we plug in our x values. So this is going to be here, and when you plug in 0, you're just going to get 0, and when you plug in 1, we're going to get -1, and when you plug in 2, we're 16. So from our table, we can see that this is the highest y value, and this is the lowest y value. So now, since we compared our y values, the highest y is going to be our max, and the lowest is going to be our minimum. So now we can say, let's just label this max, and this min. So now we can say that our max point is at 2, 16, and our minimum point is at 1, -1. And that's our final answer. Okay, question 2 we have, find the maximum minimum points on the interval -2 to 2 for the function 2x over x squared plus 1. So first of all, let's label our endpoints. So we have x equals -2 and x equals 2. Now let's find our critical points. To find this, we need to find the derivative of the function where the derivative is 0 and undefined. So let's find the derivative on this side over here. So f prime of x, we have to use quotient rule here. So u equals 2x, v equals x squared plus 1, du equals 2, dv equals 2x. Now let's do v du, so 2 times x squared plus 1 minus u dv, 4x squared, all divided by v squared. And now when we simplify, we'll end up having 2x squared plus 2 minus 4x squared, all divided by x squared plus 1 squared equals 0. Now, to get our points of horizontal tangency, we have to set the numerator equal to 0, and to get the points of our vertical tangency, we have to set the denominator equal to 0. And in this case, we can, because we have a denominator where we can set x equal to 0. So let's solve it on the side here. 2x squared plus 2 minus, I guess we could just say negative 2x squared. 2x squared minus 4x squared equals 0. Now, we can simplify, we can divide by negative 2 on both sides, so we'll end up having x squared minus 1 equals 0. And now we'll have x equals plus minus 1. So we have 2 points where there's a horizontal tangent line, 1 and negative 1. And now let's do the vertical line. So x squared plus 1 squared equals 0. Then we'll end up having x squared equals negative 1, square root both sides, and you'll end up having x equals square root negative 1. And this is an imaginary number, so we cannot work with this. So even though we have a denominator, the value isn't a real number, so we can't use it. So this is the only value we can use. So now let's put our critical points. X equals negative 1 and x equals positive 1. Now we have 4 values of which that can be maximum or minimum points. So let's make our table again. X and f of x. And let's label all the points. Negative 2, negative 1, 1, and 2. Now when you plug in negative 2, negative 1, 1, and 2 into f of x, you'll get these values here. Negative 4 over 5, negative 1, 1, and 4 over 5. So from this, we can see that 1 is our biggest value. So we can say this is max. And negative 1 is our lowest value, so we can say this is our min. So now, we can just say that our max point is at 1, 1, and our min point is at negative 1, negative 1. And this is our final answer. Okay, question 3 we have, find the maximum minimum points on the interval 0 to 3 for f of x equals ln of x plus 1. So our endpoints here are x equals 0 and 3. And let's find our critical points. So the derivative of f of x, which is ln x plus 1, just by using the chain rule, we can see that it's just going to be 1 over x plus 1. Now let's set it equal to 0. Now our numerator is just 1. So 1 is not equal to 0. So we can say that there's no points of horizontal tangency. Now let's look at our denominator. X plus 1 equals 0. Now subtract 1 on both sides and we'll get x equals negative 1. This is where there's a point of vertical tangency, where the slope is undefined, or a straight line, a vertical straight line. But this is in the interval 0 to 3. So even though there is a point of vertical tangency, it is not in the interval that they're asking for. So because it's not in the interval, we can't use this either. So if you find yourself getting a point of horizontal tangency or vertical tangency, but it's not in the interval, just remember you cannot use it. So unless this extended to -1 or anything less than that, then you could use it. But since we cannot, we can only use the endpoints to find our max and min points. So now we don't have any critical points. So now let's make our table. X and f of x. So we can only use 0 and 3. And ln of 1 is always going to be 0. And ln 3 plus 1 is ln 4. That's going to be around, well, it's always going to be bigger than 1. So we can just say that this is our max point. And this is our min point. And we know ln 4 is going to be greater than 0 because e to the something is 1 point something something something. If you approximate, you'll get something like that. But we know it's greater than 0. So we can just say our max point is 3 comma ln 4. And our min point is 0 comma 0. And this is our final answer.